Hearing loss is a pervasive and growing global issue. Currently, approximately 466 million people are living with disabling hearing loss. In the United States alone, over 250,000 individuals use American Sign Language. Deaf individuals often struggle with spoken communication, especially those who have never heard it before. Sign language offers a visual alternative, translating spoken words into a more intuitive format. For bilingually deaf individuals, sign language or an interpreter provides a more comfortable communication method than verbal speech. While sign language offers an effective means of communication, it's not widely understood by the majority of the global population. As a result, individuals who rely on sign language often find themselves unable to use it as frequently as they would prefer. In our project, we set out to develop a computerized system capable of recognizing and translating sign language into spoken languages. This solution aims to function as a personal, readily available interpreter for those who use sign language, enabling them to communicate effortlessly with everyone, regardless of time or place.
In order to achieve this goal, we aim to develop a machine learning-based translation system to bridge the communication gap for deaf people. Recognizing the complexity of this endeavor, including the diversity of languages, data scarcity, and other challenges, we sought collaboration with the experts in the field. We reached out to Dr. Amit Mor-Yosef from the University of Zurich, who has been leading a dedicated international research lab focused on this exact purpose for several years. Ultimately, we had the opportunity to join his research efforts with the aim of making meaningful contribution to his ongoing work. The translation process begins with a video of a person speaking in sign language. The first step is to analyze the video and locate at each frame the locations of the joints of the speaker's body. Extracting those joints and normalizing them results in an unbiased skeleton of the person, also known as the pose. As in spoken sentences, poses are constructed of several signs representing words. The second step is marking the timestamps of the different signs in the sequence, which is called the segmentation of the pose. Our efforts focused on the next step, translating poses of the speakers into the formal sign writing representation, also known as FSW. FSW is a visual, image-based language that captures and describes the movements depicted in a sign language sequence, and can also be written textually. The last step of the process is the translation to the chosen spoken language, which is the ultimate goal of this pipeline.
Through extensive experimentation, we successfully tailored the model that accepts video input and results sequential output, which can be used for the transcribing into sign writing. In order to evaluate our model in a way which takes into account the semantic space and relations, we've developed the FSW similarity metric, which accurately captures the similarity of FSW symbols. This metric considers the different components of the FSW symbols, such as shapes, orientations, rotations, and locations. Using weights determined through manual experimentations, it allocates importance to each component and calculates similarity of the overall sequences. We believe this metric provides a great value to the field of model evaluation using sign writing.
The data scarcity and complexity of this field makes supervised learning a difficult task to achieve. Therefore, we have developed the synthetic sign language method. Using it, we are now able to generate unseen videos of sign language automatically, and by that expand our database further beyond the limitation of the currently available live footage data.
Building on this foundation, our model marks a significant advancement in the task of transcribing poses into FSW symbols.
Despite the research nature of our project, we decided to provide users with the ability to utilize the pipeline of this research. Users are now able to upload their sign language videos to the site, choose a sign language, and receive information and results from different parts of the pipeline. The main page presents the outcomes of this research. These include translation of the video into 3 useful formats: English text, FSW meaning, and verbal audio. You can now also download the pose of the video, as well as the video embedded with the verbal and sound writing translation over it. Another, more scientific tool we incorporated in our site is the Similarity Score Calculator. This feature allows users to experiment with FSW in an easier way and try out our similarity metric themselves.
Toward the end of our work, together with our mentor Amit, we decided to publish our novel symbol distance metric in an academic paper. Our paper has been submitted to peer review in hopes for our metric to be adopted by the community of the field and make true difference in future work.
Rotem and Ohad have done outstanding work, and we can now integrate their contributions into our sign language translation pipeline. The process starts by transcribing the video, followed by translating the sign writing notation into spoken language. This can now be done in a text-to-text manner, similar to how we handle other spoken languages. This brings us one step closer to improving accessibility for the deaf community, making information more inclusive and widely available.